Hello ladies and gentlemen, we're going to do 6.2 today. We're going to apply properties of rational exponents. Our objectives are to simplify expressions with rational expressions, and we're going to do that using our properties of exponents. Now we've already learned the properties of exponents, so I'm going to go back and review those just a bit. Alright, so here's going to be your review, and I'm going to review our properties of exponents. You remember we just learned this in the last chapter. Okay? If I have a to the m and I multiply by a to the n, noticing that the bases are the same, then I'm going to do a to the m plus n. If I do a to the m raised to the n, a power to a power is multiplied, so this is going to be a to the m times n. If I have a, b to the m, that m gets distributed to everything on the inside of the parentheses, so this is going to be a to the m, b to the m. Okay? If I have a divided by b raised to the m, again that m gets distributed to everything on the inside, so it's going to be a to the m divided by b to the m. Alrighty? If I have a to the m divided by a to the n, noticing that the bases are the same, this is going to be a to the m minus n. And the last one is if I have a to the negative m, that means it's going to be 1 over a to the m, because a negative exponent makes our expression change locations. So now what I'm going to do is use the properties that we've already learned and apply those to rational exponents. Okay? So this is our review part. Now let's just do some examples. Okay? Alright, so I'm going to say simplify, kind of as our generic directions, and here's our first problem that you can't see. Sorry. Alright, now you can see it. I'm going to have 5 to the 1/2 power multiplied by 5 to the 3/2 power. If the bases are the same, I add the exponents at the top, so this is going to be the 5 to the 1/2 plus 3/2. 3/2 plus 1/2 is going to be 5 to the 4/2, which is 5 to the second, which is 25. Now a lot of these you can do much of the math by hand without having to bring in your calculator. Next one, I'm going to have 3 to the 5/2 raised to the second power. So remember, a power to a power is multiply, so that's going to be 3 to the 5/2 times 2 over 1. The 2's cancel because they're multiplied together, so this is going to be 3 to the 5 over 1, which is just 3 to the 5th, and that's going to be 243. All right. Our next example would be 16 times 9, and both of those raised to the 1/2 power. Remember, this 1/2 applies both to the 16 and to the 9, so I'm going to rewrite it as 16 to the 1/2 times 9 to the 1/2. And I'm going to rewrite it a different way, as I'm going to write it as the square root of 16 times the square root of 9, which is going to be 4 times 3, which is 12. And again, I'm only considering the principal roots, because technically it would be plus or minus and plus or minus, and that would be our answer, but we're only considering the principal root. Now for D, I'm going to have 4 to the 5/2 divided by 4 to the 1/2. Remember, if the bases are the same and I have division, that means I subtract, so this is going to be 4 to the 5/2 minus the 1/2. So this is 4 to the 4/2, which is 4 to the second, which is 16. Okay? And then our last example of these is going to be 27 over 64 raised to the 1/3 power. Remember, this 1/3 applies to the 27 and to the 64, so I'm going to rewrite it as 27 to the 1/3 power over 64 to the 1/3 power. So this is take the cube root of 27, which happens to be 3, and the cube root of 64, which happens to be 4. And there is my solution. All right, so let me turn the page, get us some clean real estate. All right, so now let's do some more work with simplifying our equations. See if I can make my Zoomer happy. So I'm going to start some more examples, and again, they're just going to say to simplify, except I think I forgot how to spell FY. Whew, there we go. All right, so my first problem is going to be 7 to the 1/4 times 7 to the 1/2. Okay, the bases are the same, so I add across the top, so it's going to be 7 to the 1/4 plus 1/2. But I can't add those two fractions together unless their denominators are the same. So I'm going to multiply this fraction by 2 over 2, which is 1. So now I have 1 plus 2. So this is going to be 7 to the 3/4. And then I could do that math in my calculator, or I could just rewrite it. And for today, I'm just going to rewrite it. I'm going to write that as the 4th root of 7 cubed. Okay? I could do that in my grapher. I can't do that by hand. So if I raise 7 to the 3/4 power, I would get 4.304. And remember, we're always using 3 decimal places. All right, my next example, B, I'm going to do 6 to the 1/2 times 4 to the 1/3, and I'm going to raise both of those to a second power. A power to a power is multiply, and I'm going to manage each piece separately. So this is going to be 6 to the 1/2 raised to the second times 4 to the 1/3 raised to the second. So a power to a power is going to be multiply. So this is going to be 6 to the 2 over 2 times 4 to the 2 over 3. Okay? 2 over 2 is 1. So this is going to be 6 times 4 to the 2/3. Okay, remember that the 2/3 only applies to the 4 because it applies to what's directly in front of it. So now I'm going to do that math on my calculator. So I'm going to do 6, and then I'm going to do in parentheses 4, and then I'm going to raise that to the 2/3 power. Oops, I forgot the 3/3 power. Okay, and I get my solution is 15.119. All right. I could have done it a different way. I could have done 6 times 4 and raised that to the 2/3 power, and I get the same answer. So either way, the glare is really bad. Either way was okay. All right. See if that helps at all with the glare. All right. Next example, I'm going to have 4 to the 5th times 3 to the 5th raised to the -1/5. And I'm actually going to manage this a little bit different. Notice that both of the exponents are the same, but the bases are different. So now I'm going to do 4 times 3 raised to the 5th, and then manage that -1/5 on the outside. So now this is going to be 12 to the 5th raised to the -1/5. A power to a power is multiply. 5 over 5 is a -1, so it's going to be 12 to the -1, which is 1 over 12. And I can leave my answer as a fraction like that. That's very polite. Okay. I have 2 more of these. My next one's going to be 5 over 5 to the 1/3. Okay. If the bases are the same, I subtract the exponents. Remember that that's the same thing as saying the 5 is raised to the 1 power. Okay. I can't subtract unless they have the same denominator, so I'm going to rewrite this as 3 over 3, which is 1, over 5 to the 1/3. Now I can subtract because the numbers are polite, minus 1/3. There's my exponent. And I'm going to get 5 to the 2/3. Okay. Bring in my handy dandy calculator. I do 5 raised to the 2/3 power, and I get 2.924. Again, these are very nice. All right. Last example for these looks a little bit more entertaining. I'm going to do 42 to the 1/3 divided by 6 to the 1/3. Notice the bases are the same, or different, but the exponents are the same, and then I'm going to raise that whole mess to the second power. I'm going to rewrite the insides, since the exponents are the same, as 42 divided by 6 raised to the third raised to the second. 42 divided by 6 is 7. A power to a power is multiply, so I have 7 to the 2/3. Bring in my handy dandy calculator, see if I can get the glare to not be so bad. 7 raised to the 2 divided by 3, and I get 3.659. Remember, we always want 3 decimal places. Alrighty, now we're going to do just a couple of properties of radicals. This has probably been a while. We've done a little bit of work with radicals this year, but not a lot. So if I have the nth root of a times b, I can rewrite this as the nth root of a and then times the nth root of b. Okay, so I can split a radical that's multiplied together up. Same thing if it's division. If I have the nth root of a divided by b, then that's the same thing as the nth root of a divided by the nth root of b. So I can manage those two things a couple of different ways. Alright, so now let's do a couple of more examples. We're actually almost done. Yay for a couple of short videos. Woohoo! Here's your first problem. That's an A, by the way. It looks like a 9, but it's an A. I want to simplify the third root of 12 times the third root of 18. Alright? I'm going to simplify that because the roots are both the same, so I'm going to multiply, leave the third root, and this is going to be 12 times 18. I can't do that math in my head, but I'm going to do it on my calculator, and I would get that I want the third root of 216, and that's going to be 6. So remember, in my grapher, I would do 216 caret 1 divided by 3, and then I would get a 6. I'm going to change that to an A just so it looks a little bit better. There is a different way that you can do these on your calculator. I don't usually use it because it takes longer to get to it. It's under the math operations, and then you have to remember which number comes first. If I just enter my fractional exponents, it's very simple to manage. So I always do mine this way. Alright, so now let's get to your next example. Here's B. Remember, we're just simplifying. So now I'm going to have the fourth root of 80 divided by the fourth root of 5. And just as a reminder, remember that a fourth root would be 4 of the same number multiplied together. The roots or the indexes are the same, so I'm going to rewrite this as the fourth root of 80 divided by 5, which is going to be the fourth root of 16. And then I know that the fourth root of 16 is going to be plus or minus 2. It's plus or minus because the 4 is even, and 2 to the 4th power equals 16. Alrighty. Let's do another one with as an example, and I'm going to do it a slightly different way. So this one says to simplify, and I'm going to have the third root of 135. So I could do this on my calculator, and I could do 135 raised to the 1/3 power. But what if I ask you to leave this in simplest radical form? That means that you really don't get to use your calculator. You have to do things by hand. So I'm going to go back and remind you how to do a factor T, because we've done these before. Remember that my prime numbers go on the left, my answers go on the right. I'm primarily concerned with just these numbers on the left. So I'm going to start by dividing by 5, and I'm going to get 5 goes into 13 2 times, it leaves 35. 5 goes into 35 7 times. 3 goes into 27 9 times. 3 goes into 9 3 times. 3 goes into 3 1. When I get a 1 on the bottom right, I'm done. Now remember, our index told us that we needed to do the third root. So instead of doing numbers in pairs, now I'm going to do numbers in threes. The 5 has no friends, he stays inside, so this is going to be 3 radical 5, and the radical is the third root. So that would be my answer in simplest radical form. All right, just a reminder, because in theory you did learn this in Algebra 1. If I want to add or subtract radicals, two things has to happen. They have to have the same index, which means what root are you taking, and they have to have the same radicand, cool word, which means it's what's underneath the house. Okay? I guess you can't see that. Sorry. Alright, so if I want to add or subtract a radical, they have to have the same index and they have to have the same radicand. If they don't, then you have to simplify them before you can add them together. Alright, so let's do an example of these. So I'm going to have the fourth root of 10 added to 7 times the fourth root of 10. Notice that both of my radicands are the same and both of my indexes are the same. And this is just like factoring. I'm going to put a 1 out there because if it's not there, it's not a 0. It's always a 1. Okay, they have the fourth root of 10 in common. So this is going to be 1 plus 7. Those numbers play together times the 4 radical 10. So this is going to be 8 to the fourth root of 10. And that would be my answer because that is simplified or added together. All right, let's do another one of these. Okay, my next example, I'm going to have the third root of 54 minus the third root of 2. But notice I actually can't do this yet because the 54 and the 2 don't match. So what I'm going to have to do is reduce the 54. So I'm going to reduce it with a factor t because I need things to be in simplest radical form. I'm going to start by dividing by 2. 2 goes into 54 27 times, and then 3 goes into that 9, 3 goes into 9, 3 goes into 3, 1. I'm taking the third root, so my numbers come out in 3. So then my first radical becomes 3 to the third root of 2 minus 1, and then this is the second radical. Now if I do this math, this is almost the same thing as doing 3x minus 1x. So I'm going to have 2 to the third root of 2. Sometimes we manage radicals almost as if they are a variable, because if I simplified it to look like this and got 2x and then substituted this back in for x, I would have the same answer. So sometimes when math looks complicated, we can substitute in a variable and it makes it look easier. You just have to remember to substitute back in for whatever we assigned the variable to be. Alright, and this little empty space right here, I'm just going to give you a note. Okay, and that note says if I take the nth root of x to the n, it's going to be whatever the number happens to be. Same thing, if I took the nth root of a negative x raised to the n, it would be the negative x. Okay? As long as I'm taking the same root as the power, it all works out politely. Okay? Alright, so now what I'm going to do, just a couple more examples, is simplify some radicals with variables. So here's our next example. And again, I want to simplify. And I'm going to have the third root of 64y to the 6th. So I'm going to split this one up. And I'm going to split it up into the third root of 64 times the third root of y to the 6th. Now you can't do the variables in your calculator. You could find the third root of 64 in your calculator, and that turns out to be 4. Okay, and we've seen that number a lot in the last couple of days. Okay, y to the 6th is the same thing as doing y to the second, y to the second, and y to the second. Because remember, if the bases are the same and they're multiplied together, 2, 4, 6, so the third root of y to the 6th is going to be y to the second. And that is my solution. So even though it looks complicated when I add a variable, I still manage the variable as if it was a number. Alright, here's the next thing that we're going to do. Again, it's going to be a simplify, but I'm going to show you a cool new trick. So this time, I'm going to take the third root of x over y to the 8. Okay, that's not y times 8, sorry, that's y raised to the 8. Oftentimes, if I want to reduce this or get rid of the radical in the denominator, we would do what we've done in previous chapters, and we would rationalize the denominator. But sometimes those get really big. So this time what I'm going to do is I'm going to make the bottom, so I'm going to make my denominator be a perfect cube. Just like y to the 6th was a perfect cube by doing y squared, and y squared, I'm going to make y to the 8th become a perfect cube. Okay, so now I'm going to multiply by y over y. Okay, remember I can do the same thing as long as I do it to the top and the bottom. So now my expression becomes, there's the third root, x times y. Remember that that exponent technically is 1, bases are the same, add, and I get y to the 9. Remember now, if I have a radical divided by a radical, I can split it up. So this is the third root of xy over the third root of y to the 9. I can get 9 by doing y to the third, y to the third, and y to the third, 3, 6, 9. So my expression would simplify to be the third root of xy that I can do nothing else to, divided by y to the third. Okay? I cannot simplify this y and this y because this one is now no longer under a radical. So if it were under a radical, it could play, but now that one's under and one's out, these two guys can't play together. Alrighty. Now let me give you your problems. Just a few to do. First set, say to simplify. And I want you to do by hand as much as possible. And even if you have to use your grapher, you need to show me all of your steps. Okay, so I want you to simplify by hand as much as possible. Number 1 is 5 to the 1/3 times 7 to the 1/4. Both of those things raised to the third. Okay. Number 2, you're going to do 20 to the 1/2 divided by 5 to the 1/2, and you're going to take that whole thing and raise it to the third. Okay. The second set of problems say use the properties of radicals and your calculator at the end if you need to. Okay, so calculator at the end to simplify. Alright, number 3 is going to be the fourth root, that's a 4, sorry, the fourth root of 27 times the fourth root of 3. And then problem number 4 is going to be the third root of 250 divided by the third root of 2. Alright, 2 more problems. Okay. I want you to simplify. So number 5 is going to be the third root of 27x to the 9. And then problem number 6 is going to be 6xy to the 3/4. Notice the 3/4 only applies to the y, and this is a 6, not a b, divided by 3x to the 1/2, y to the 1/2. And again, notice that this 1/2 only applies to the x. and this 1/2 only applies to the y. It does not affect the 3, nor does the 3/4 affect the x or the 6. All right, good luck with your problems, and I will see you tomorrow.